I just like speak into it so like they can like hear the random. Like oh,
They're going to be very appreciative that the camera was right next to Steven the entire class period.
Should I move it? I can move it.
So we should get out a different paper to write equations on.
I don't even know what
Guys,
stories to
I'll
bring
get out
up
a
right
different
now.
paper to write equations on. Most of them you have. Most of them you won't remember. Some of them you don't have. Make
For
sense?
what?
Sure.
Okay.
I'm a banana.
I'm a banana.
Okay.
I'm a grapefruit.
No, Steven. Greg.
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 Okay. Number 1. An electron is held up against the force of gravity by the attraction of a fixed proton at some distance above it. How far above the electron is the proton? So, what equation we're going to use this since we're really looking for electric force here?
Q equals MCAT.
Oh, the
Q
Q equals K.
is going to be
KED.
electric force, F electric equals K, Q1, Q2 over D squared. What's F electric in this case since it's going to be, the electric force is overcoming gravity?
Minus FG. What?
Yeah, mg. So we're going to have mg equals k q1 q2 over distance squared, and we're looking for the distance there. Alright, anybody know what the mass of an electron is?
I think that'll be impossible for them to read on.
Time to
What?
maybe.
That's the charge of an electron. Mass of an electron is 3.1 times 10 to the negative 19. 31st kilograms. Oops. 9.1 times 10 negative 34. Okay. So, I'm going to substitute in there. We have 9.1 times 10 to the negative 31st times 9.8. Anybody remember what K is? 8.99 times 10
10 to the 9th.
to the 9th. What's the charge of an electron? 1.6 times 10 to the negative 19th. And we're going to make that negative.
How do you know all this off the top of your head?
I've used it a lot. Proton is 1.6 times 10 to the negative 19th. That's just positive. And we're solving for d squared.
So I got confused because when I was doing these problems in the worksheet, remember that number was negative. So
Yeah.
Alright, we're going to end up with a... Really, when we get a negative force here, guys, I kept it there even though I know we're going to drop it. When we get a negative force here, all that's telling us is that the force is attractive. Does that make sense?
you just kind of forget about it.
So you just kind of forget about it. So I would actually just eliminate that
All right.
because we're setting up an equality here.
Okay.
So use the absolute value of the charge. Do you guys understand why?
What charge did we get rid of?
We get rid of the negative on the electron charge. Otherwise we end up trying to take the square root of a negative number.
We need some imaginary.
Yeah.
meters.
D is correct, 5.1 meters.
It's not even an answer. What did you write? I'm doing it. Oh. I told him that. I got it. We're good. Okay.
Does your
Got
calculator hate you like me now?
1.27 times 10 to the 10th.
Meters? Probably not right.
Oh wait. Oh, I didn't. Wait, are those all in meters?
You can't whistle. You can't whistle?
I can't whistle either.
I can whistle quietly.
I can't whistle and I can't snap my fingers.
I can't like
Can't
do it to a
I cannot snap.
I can listen to myself.
There have been multiple people.
Okay, guys, we're ready to move on.
You don't understand. Like there have been multiple people that have tried to teach me. I can't snap my fingers.
Yeah, I can't either. Okay.
Middle.
Everyone
Sensei,
tried to-
did you know that I can pull my lower lip below my chin?
Oh my god.
Braden's just going to be so enraged watching this. You know that, right?
Wait, that's his camera?
That's our camera I'm using to tape
Here.
classes?
I'm a banana.
Okay.
Dude, let me show. I'm actually totally starting.
By saying great.
All right.
No one can.
All right.
I don't understand.
How about we teach people physics?
You can
Does
try.
that sound like a good plan?
No.
No?
No.
Maybe so.
All right. This is gonna be online at some point. That's
It's
awful.
second semester.
All right.
Wait, you
Number
putting
two.
this on YouTube for
Wait,
that
what
or
was the
what?
answer?
That's what I'm trying to
D.
probably end up
Oh.
doing.
Okay.
Is your like,
Hey, I got it.
have you had any accounts long enough?
Yeah.
There's still the time limit if you're not special.
Guys, let's actually.
What's the time limit? I don't know.
Nope, let's
10
not.
minutes.
That's spectacular.
Yeah, because I tried to put
You're gonna have to put it on
family meal
CDs for
project
that.
and it didn't work.
What?
You're gonna have to burn it to a
Wait,
CD
why are
for
they
that.
gone?
They're at
Oh.
something for
Kairos.
Kairos.
Brayden.
Steven.
Greg!
Number 2.
That's not Brayden.
Okay.
Okay.
Jesse's also there.
Jesse.
Number 2. A force of 10 newtons attracts a charge of 5 microcoulombs when it is placed in uniform electric field. What is the magnitude of the electric field? The
Oh.
electric field is equal to the force divided by the charge. So E equals F over Q. And you see those answers, they're in the electric force unit for electric field is normally newtons per coulomb. The the units there are meganewtons per coulomb. You're gonna divide by 10 to the 6 to get to that.
My good news.
Man,
Wait,
messed my plan up for some.
the basic for E equals F over Q, it's meganewtons per coulomb.
So is it B?
Yes, it's B. The answer you'll get will be in newtons per coulomb, but all their answers are in meganewtons per coulomb.
I mean, if all other answers are in meganewtons per coulomb and you have 10 newtons in microcoulombs, it would equal out one day. Because you're making,
That would end up equaling out, yes.
yeah. So for a problem like that, if it's newtons and microcoulombs, you can just leave it. So it's 10 divided by 5b.
Yep.
Cool. That makes it a lot easier.
Okay. Can I erase these now?
Go for it.
So wait, I don't think Brayden and Jesse copied this.
What'd you say?
I don't think Brayden and Jesse copied this. I don't know.
Can hardly even like read the board on this thing.
But the screen's this big, Steve.
It's not like we don't have the
No.
equation written down.
No, it's fine. Once it's on an actual like computer screen.
Yeah, I think it'll be okay. Okay. Number 3. 3 identical capacitors are connected in parallel to a battery. If a total charge of Q flows from the battery, how much charge does each capacitor carry? So I'm going to draw this diagram out for you. So we have our battery,
Q.
and then the capacitors are the plates that store charge in each plate. Alright, so if there's a total of Q charged on these, how much is going to be on each?
Q. Over 3.
Q over 3. Because they're all equal. If they were not equal, it would be divided up proportionally. Does that make sense? So number 3, the answer should be C. Okay, number 4, materials in which the electrons are bound very tightly to the nuclei are referred to as
Superconductors.
insulators.
You're right, Matt, except the opposite.
If you multiply by answer by -1.
Superconductors times -1. Or 1 over superconductors. That would probably make more sense.
Or the opposite.
Perpendicular.
Okay. Alright.
Well, that'd be a super insulator. So then you have to, it's times -1 divided by super.
Okay, we're done.
No.
Alright,
That's
potential
how the
difference
50
between the
trouble.
terminals of the battery when current flows to an external circuit is referred to as
Terminal voltage.
terminal voltage. EMF is actually another way to say voltage, but it's not until we get to magnetism that we'll start talking about that, and motors and things like that. EMF is
Electromagnetic
called
force.
electromotive force.
Oh.
Alright,
Thinking of EMP, but
6. A dielectric material such as paper is placed between the plates of a capacitor holding a fixed charge. What happens to the electric field between the plates?
What does dielectric mean? I'm saying no change.
It's like basically something that doesn't conduct electricity.
no change, eh?
It becomes weaker. You gotta think about it this way. If you have like nothing in between, there's nothing interfering with that electric field. When you put stuff in between, it does interfere. Does that make sense?
Okay.
And the more it insulates, the more it's going to interfere. Does that make sense?
If it's like copper, would it be increasing?
Copper would increase the electric field, probably. Would increase the well, copper would be a different story entirely, because if you put copper in between, it's going to discharge the plates, so it's going to eliminate the electric field. Elizabeth, you having fun back there?
Are you made of copper and tellurium because you're CUT?
Okay. All right. So and when you put something in between, like when you put an insulator in between two plates, it increases the capacitance as well. So if you put paper in between the two plates of a capacitor, because it decreases the electric field, that allows more charge to be stored on it. Does that kind of make sense to everybody? Okay. Alright, number 7. As more resistors are added in series to a constant voltage source, the power supplied by the source
Does not change.
It's the equation. I forget what.
It's one of those two. It
Right.
doesn't decrease.
you're adding more resistors in series. So what happens to the resistance?
Goes up.
Increases. What do you think is going to happen to the power?
It'll increase.
Supply.
The power supplied
The
The
by
power supplied by the source won't change.
It'll
Though.
increase.
I'll tell you the answer, then we'll go back and explain it. It decreases.
No.
So
Because what goes in has to be. What?
Why?
Doesn't make sense.
what really matters for the power dissipated, let's look right down the power equations here. So we
But
have
the power, like the initial power, wouldn't change, would it? The initial power changes. The
the
power
more
supply.
resistance you have, the less current and power is drawn for a given voltage. So if we have P equals IV, or I squared R, or V squared over R. Are the I equations going to be appropriate if we're keeping the voltage source constant but changing the resistance? No, the I is going to be changing. Does that make sense?
Okay.
So in this one, the voltage source stays constant. We've increased R, and P is going to decrease. Or if we look at these two equations, we can say R is going to increase with the same voltage source, so I has to decrease. Does that make sense, everybody? Okay. Alright. A surface on which all points are at the same potential is referred to as. What do you guys guess?
Potential surface.
Equipotential surface is correct.
That's what I was thinking.
Alright. If a copper 2 plus ion, what is that? Cuprous or cupric?
Cuprous.
This is going to be proud.
Cupric is Cu3 plus.
Yeah, it is.
Isn't it?
No. It's opposite. Cu plus is cuprous,
Cuprous.
and Cu2 plus then is cupric.
So it's cupric. I never know those.
You could just say cupric.
Proves that they're not
I would
necessary.
That was always
Copper 2.
That proves that symbol quizzes are not necessary.
Okay, so it drops the potential difference of 12 volts. It will require a kinetic energy in the absence of friction of. Okay,
1/2 mv squared. And I can.
this, you can do this, you can do voltage equals potential energy over charge is the equation you'd use. If there's an easier way to use it, so voltage equals electric potential energy over our charge. But, do you see how the answers are in electron volts? What's the charge in electrons of copper 2?
Well, there's 2 of them.
So you have 2 extra protons, so it'd be 2 times the charge of one electron. The units are, these EVs are all electron volts. How do you think you get to those units?
Electrons times volts.
Electrons times
I'm gonna
volts.
say it's D.
So it is D24.
Did that
So if you have electron volts and you have the charge in terms of electron, you can multiply by
Volts by how many electrons? Or electron charges.
Extra electrons.
I mean, there's extra protons.
extra protons in this case.
Yeah,
Oh, is it?
but the charges are
D.
equivalent.
So it's
it
just
doesn't
12
matter.
times 2 extra electrons.
So if it was a minus, then it would just be a negative number,
If it was a minus, it would be
or would it stay the same?
kinetic. It's asking for the kinetic energy, so it's going to be positive no matter what. Kinetic energy, you can't have negative kinetic energy.
You think so, huh?
know so. Because it's 1/2 mv squared.
You think so, huh?
What if you have negative mass?
Can't have
What about
negative-
outside the universe where there's less than nothing? That means there's negative energy, negative change. Which
I'm a
means-
banana.
Oh.
That's exactly what Braden would have said there.
Okay, done.
Yeah!
Okay,
That.
I don't know that I'm ever going to push this to anything. Alright, number 10. An electron and a proton are separated by a distance of 1 meters. What happens to the size of the size of the force on the proton if the electron is moved 0.5 centimeters or 0.5 meters closer to the proton?
It increases.
Well, it's squared, so.
It's going to increase by 4 times the distance because the distance
Yeah.
is squared.
Pretty sure every time you ask a question about distance changing, it's always 4 times.
What if it was a third closer? Then
Ooh,
it'd be
got it.
9
9
Nine.
times.
Okay, number 11. The network done moving an electron from point A, where the potential is negative 50 volts, to point B, where the potential is positive 50 volts, is.
What?
Okay, so we're going to same equation. This equation here, V equals PL over Q. So what is our voltage going to be?
Find
100.
minus initial, so 100.
100. We're looking for the work done is going to be equal to the potential energy gained. Does that make sense to everybody? And what's our charge of 1 electron?
The one thing that I wrote down.
Times 10 to
Negative 1.6 times 10 to the negative 19.
Okay.
Well, you don't have to worry about the negative, do you?
No, if you look there, there's an answer with a positive and a negative sign.
Oh, you do.
So you do.
Well, all you do is just take B then, obviously.
Forgot hair tie. It's tragic.
And if you try to,
Oh, none of the given answers, so I probably should work it out, but I won't.
so the answer is B. Does that make sense to everybody? So if it was a proton, the network would be positive.
Ah,
Okay. This is one you do not have the equation for.
sweet.
The temperature coefficient of resistivity of platinum is 3.9 times 10 to the negative third, and that's 1 over degrees Celsius. It's just kind of a ratio of that. If platinum wire has a resistance of R at room temperature, 23 degrees Celsius, what will the temperature must be heated to in order to double its resistance? Okay. So the resistance
46.
of anything
So go to the temperature times
is
that.
its resistance at a certain temperature plus times 1 plus alpha
We go into Celtic.
delta T.
Beautiful. Is alpha the resistance
Alpha is the
of
coefficient
whatever?
of resistivity.
Wait, do we even have that equation?
Arcibo is the
He said no.
original resistance.
so we
So in
need
this
to know
case
it.
it's R.
Alright.
He's mad at me.
They are? Yes, yeah.
Hey, Lisa, I was by your house last week.
Greg! Didn't you already share that story?
Not today.
Oh my gosh.
Make sure you guys let
I
Braden
swear
know
we
that
hear
you
that
should
once
get
every
right
day.
next to Steven.
I think I'll know.
Make sure you guys let Braden know that, like today probably, just to get him riled up, to make sure let him know that we put the camera next to Steven for the entire class. Hey, how are you guys doing on this?
Wait, so
Oh, we're not talking. Okay.
you're looking for delta T. So 2R equals R times 1. Is that what you fill in?
You feel 2R equals R times 1
Steven.
plus,
Steven.
1 plus
Alpha T.
3.9.
Wait, what is it?
Can you write
Is it
that on the
A?
board,
Yeah.
please?
but
Can you write this on the board?
sure.
What is
So our the resistance we're looking to find is when it's doubled, so it's going to be 2R equals R
Well, you divide by R and you get
times
2.
1 plus, what's the alpha?
3.9 times 10 to the negative third.
And delta T. So we
Minus
drop
1.
our R,
So,
and we get not the 2, the R.
So it ends up just being 1 divided by 3 divided by that.
It's a
Then.
permutation.
1 plus 3.9
About that one.
times 10 to the negative third delta t.
256.
Oh, okay.
You actually changed the temperature. 23, 256.
Like the password is.
279. A.
A.
Slide.
Does that make sense, everybody?
I can figure it out.
Okay.
We'll try again in a minute.
13. How much does it cost to operate a 25-watt soldering iron for 8 hours if energy costs .08 or 8
8
cents
cents.
per kilowatt hour? Okay, so a kilowatt hour is a kilowatt times 1 hour. So,
Okay, so
if you
you
operate a 1 kilowatt device for 1 hour, you're operating it at the energy expended is 1 kilowatt hour. Does that make sense to everybody?
0.0005.
So you're gonna have 0.025 times 8 hours is gonna give you the number of kilowatt hours.
Should be 0.025 or 0.00.
It's about 25 divided by 1,000 to get to kilowatts. It's 0.025, isn't it?
Yeah, right.
Is that what
I don't know why I can't think.
Okay, so
My head hurts. Times
so how many kilowatt hours is that?
0.2.
0.2.
And then you multiply that by the cost.
Yep. So it's 0.2 times 0.08,
So 0.016.
0.016. So D. Does everybody understand how to do one like that? It's
What
really just
equation?
kind of an exercise in conversion stuff. Alright. 13. How much does it cost to operate a 20? That's what I just said.
We
14. Is it possible to have zero electric field between 2 positive charges along a line joining the 2 charges?
I'll throw a B. Oh no, that doesn't seem right. But
I would say always trust Eric. The answer is B. So,
Okay, why?
let me erase
I just assume since they were different magnitudes, that means one's slightly more plus.
Yep. So like if you have positive charge here and a positive charge here, the electric field tells you like what force a positive charge would experience. So is there anywhere between these 2 charges where we could get a positive charge experiencing no net force? So, like,
Apparently,
what-
yes.
So if these were equal in the dead center, the positive charge would be repelled equally by both of them.
Oh, okay.
Does that make sense?
So it's just where the fields touch, pretty much.
Yep, and if one was bigger, it would be further away from that,
That
the
makes
larger
sense.
charge. Right, 15. 3 times 10 to the 15th electrons flow through a section of wire of diameter 2 millimeters in 4 seconds. What is the current in the wire?
Equation, please.
Current equals charge over time.
Wow, that's easy.
So is there extra information in this?
The amount of electrons.
So
Nope.
I equals a QT then.
Yes.
I'm a Q
Ha.
is what we're
Ha.
trying to say.
So funny. That was so funny.
Alright,
I mean,
It's better than Alex Israel joke to do.
That was,
That was
bad.
that was bad.
The,
okay.
I
the
knew
diameter.
That place Israel.
Yes, Stephen, we don't need the diameter.
When Dietrich was talking about.
So how do we find the
multiply electrons
Charge.
by charge.
And he was reading it.
Multiply the number of electrons.
General
by the charge of 1 electron? So it's going to be 3 times 10 to the 15th times 1.6 times 10 to the negative 19th.
So it's 3 times negative
That'll be
1.6 to
4.8
the
times 10 to the negative 4.
answer e to the negative 4.
I was like, go. Keep going.
And all
Anyone
the
else
answers.
get negative 4.8 e to the 10 times 10 to
We want the it's just the charges flowing past, so the positive and negatives don't matter, so don't make it. Current's always going to be positive, I guess is what I'm saying.
I did not get a real answer.
So what is it?
Then you multiply.
It should be B. Do you want me to do it?
Yes.
How do I say that?
Wait, okay.
Alright, so you got
3 e to the 15
I
times.
equals Q over t.
Negative 1.6 e to the 19.
Our Q is going to be 3 times 10 to the 15th electrons times 1.6 times 10 to the negative 19th coulombs per electron divided by 4 seconds.
It's your negative 4.8 e to the negative 4. You divide by.
About 1.2
Because you need to convert it
I
to
got a
mega
negative.
amps
Yeah.
You have to
That's
convert.
still not.
Oh, milliamps.
or
Okay.
milliamps or
So you times it by
whatever.
100
Or yeah,
then.
milliamps.
It still doesn't.
And then you get negative 0.012.
Negative 4.
Are none of those answers right?
No. The answer should be negative 0.012. If
No,
Mel-
just
Millie's 5, no, 0.1, no, yeah, A is right, except it's negative.
It's not negative.
What, yeah,
not
so A is right.
So A's right? Oh yeah, I read the wrong answers. Is A not right?
I got
A is right.
I got 0.012.
No, Millie's 1,000, my bad. If you're listening to me.
That's fine.
I definitely got
Let
A.
me plug it in.
No, because you get negative 1.2 e to the negative 4, you times it by 1,000 for Millie, you
Okay.
get negative 0.12.
Still probably not.
Yeah.
That was only
We're good?
We're good.
Okay. So A.
I just didn't know what Millie was, I thought it was Senti for some reason.
Okay.
Very clever.
Number 16. What is the resistivity, or what is the resistance of a 1 meter of number 18 copper wire? Copper wire has a number 18 copper wire has a diameter of 0.4 inches. That's going to be a pain. The resistivity of copper wire is 1.68 times 10 to the negative 8
So use that same resistance thing?
resistance per meter. So the resistance is going to resistance of a length of wire is R equals rho, which is the resistivity, times the length over the area.
Wow.
Useful conversion,
Wow.
2.54
Wow.
centimeters equals 1 inch.
Wow.
Row.
Wow. Wow.
Gently down the street.
Wow.
Wow.
Wow. What is that, 2.54?
Centimeters and 1 inch, because it
Oh.
gives you the diameter in inches and you need it in centimeters.
I'll write that down on here just for fun. Wow. Wow.
You doing okay, Elizabeth?
Wow.
Yeah.
Wow.
Can you stop with the lab?
Wow. So the length is just 1 meter.
It's gonna be really, really long. What?
Shoot, I did that wrong. Wait, it ends up to 1.68. Answer.
Hi, I have returned. Steven, you want to stop the video now?
You don't want to
Bye.
watch it.